Good morning,
Good
everyone.
morning.
Welcome back to Super Science Saturday. On a Saturday this time.
On a Saturday, yeah.
We thought we'd get consistent.
I think, given the title, we should stick to Saturdays as much as
so we hope you're all having a lovely Saturday. Hope you enjoyed the live Q&A that we did yesterday.
With
that
Nora,
was fun.
really
with
cool
Nora
questions.
Patton. You can actually watch that back because that was super fun. Because it was Space Week. It's still Space Week technically.
Last day of Space Week is today.
Last day of Space Week, but space never stops. Space never ends. It's actually getting bigger all of the time.
Yeah,
literally.
Like, is Space Week going to get longer and longer and longer as the years go on?
The length of Space Week should be proportional to the increasing distance and size of the universe. I think
we gotta ring some people. We gotta tell them.
We gotta make some calls. But it's also another very important week starting today.
Today, there's a bit of an overlap going on.
Bit of an overlap. It's Maths Week.
Woo, 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 woo.
Awesome. So Maths Week starts today, so that's kind of the inspiration of this morning's show.
Yes.
Mathematics, which we're super excited about.
Mathematical sciences.
Mathematical sciences. We're going to teach you some puzzles, some tricks, some things you can do to wow your friends at home. Some really, really cool things. So lots of fun things happening for Maths Week. So there are, again, lots of events happening around the country.
Yeah, so Maths Week is going to run from today being the 10th of October all the way through to the 18th of October. So slightly longer than a week.
So Maths Week is from the 10th to the 18th.
Yes.
Okay.
10, 11, 12. First. 10.
Ali, can you check my calculations? Maths Week is longer than 7 days?
Yes.
I'm going to make some more phone calls.
Make some more
top
calls
up on credit. I'm going to get more credit. I'm going to make some phone calls to the Maths Week people. You know, Maths Week is technically longer than a week.
Maybe it's because of that overlap day with Space Week. They're like, Space Week stole a day from us. We gotta steal it back on the other end.
Nice. Maths and space crossing over, as they do in reality anyway.
Yeah, true.
Yeah, so there's lots of really cool events, virtual events that you can do, and you can check them out on the Maths Week website.
Yes.
We'll tell you more about that later and tell you some cool resources that you can use as well at home or in your classroom or wherever you want to use it. But we've got some cool things. The park.
Science in the park.
Science in the park. Maths in the park.
Maths in the park.
Yeah, that's what Newton was doing. Under the tree on a sunny day,
just chilling, reading,
checking out the cricket players over on the field.
Probably watching a squirrel.
That's watching a squirrel. Apple falls on his head.
Do you think a squirrel just dropped the apple
concussion.
on his head?
Could be.
Maybe
instead of Newton's laws of motion, Timmy the squirrel's law of motion.
I think so.
Yeah.
He's not getting the credit he deserves.
All right, the theory of gravity, we'll dispute this and we'll follow this later. More news on that next week.
Yeah.
So I think we'll kick off though with the solution to last week's challenge. Your challenge last week.
So for Space Week, I set you guys a challenge using our good friend Spudnik.
The Spud.
Spudnik here.
Good to get the Spud back. Thank you for clearing your calendar. It was difficult, but
we really had to talk to the Spud's agent for a while.
Made it
we had to speak to Mr. Tato to ask if we could use his image, his likeness.
It's likeness.
It's Mr. Tato.
Yeah, sure.
So the challenge I set for you was to try and push a straw through your potato. So you might have found it's quite tricky. Your straw is quite brittle. It ain't going through. But what you can do is, if you cover the top of your straw with your thumb, like that, you're trapping the air inside, which gives the straw a little bit more strength. I gotta make sure I don't stab myself doing this. Oh, I broke my straw.
You broke the straw.
Good thing I have
emergency
a spare.
straw.
Good thing I have a spare. Can I have a scissors, please?
Yes.
I need to cut the bendy bit off your straw.
Okay, that's good advice. That's good. Cut the bendy bit off.
Yeah. Okay.
Then you gotta loosen your rotator cuff up a little bit.
Okay. Straw. Did it come through? Nope. Excuse me a moment. As with previous challenges, I got it before we went live.
There's
two holes in my spud here. You can see where
there are holes to prove through. Do you need another straw? Do we have another straw?
Yeah.
You've absolutely battered the spud though.
I know. Sorry, Mr. Tato.
This is something. Try this at home. Very simple. Get a spud, which we all know are around the house. Get a straw, cut that bit off, and
didn't get quite the whole way through.
Get a gym membership apparently.
Oh, there's some potato juice leaking out through here, so it did get punctured.
Well, it is getting punctured. I can see that.
I should use a smaller potato.
Please, everyone, and thanks to everyone who's watching.
Oh, there's
good morning,
stuck
Ursa.
inside the straw.
Good morning, Ursula. Good
Anyway,
morning
that's
to
how it
everyone
works.
that's watching. Please do try this at home and send in your videos
No.
to show Ali how you can do it. So send in your videos, pictures to
This
the
is the
Explorium
worst.
social media account and show Ali how to do it.
Yay!
Praise the Lord!
We got
Nice.
there in the end.
Okay,
And
there
there's a
we
little
go.
plug of
That's
potato.
it,
It's like,
okay.
oh!
Eat it, eat it, eat it, eat it, eat
Don't
it,
eat your
eat
science.
it, eat. Oh, fine.
Don't
that's
eat your
fair.
science.
That is one of our number one rules. Never eat
So
your
straw
science.
through your potato.
Gladly leave that out of the way. So we are going to celebrate some maths with some puzzles and some challenges.
Yeah.
Now, mathematics is everywhere, and I actually studied maths in college.
Oh,
so I
you did,
studied
yeah.
theoretical physics, which is the mathematics behind how the universe works. And that's what's awesome about maths, because maths is the language that describes how things work, and you can use it to describe things that are happening currently. But the awesome thing is you can use maths to predict what will happen in the future, and that's what we do many times with weather predictions and things like that.
That's insane when you think about it.
Absolutely. So maths is extremely useful. It's behind everything you do, and understanding maths can help you make predictions, help you make better decisions, and without maths we'd be lost. From everything from how our phones work, how the satellites work, how the TV works, how all of this is happening right now,
How
communicating
could
in
you
code.
keep track of the score in the sports ball?
They're in the sports ball.
Sports ball. I'm not going
Yes.
to commit to any one sport. I'm not committing to any one sport. So I'm saying the generic
It was
sports
a disappointing week for the Irish team.
It was, unfortunately.
Great week for the UCD team, and pretty bad week for the Cabintilly team. Just
ball. Just wait till next Friday.
putting that out there. Yeah, big match.
Cabo and UCD playing against each
Cabintilly
other
and
next
UCD.
Friday.
Yeah, we'll have proper. Yeah, so
Fisticuffs.
it'll be fisticuffs on a Saturday morning.
Yeah.
Now I'm going to show you that maths is everywhere around us, and everywhere even in the universe. All of these mathematical patterns are hiding in plain sight throughout the whole natural world. So you can see even from the delicate spiral of the seashell there to ridges of majestic mountains. You can see the kind of different mountains there, even to the structure of the universe itself. So everything we do, walking, breathing, hearing, even singing, has patterns that we use every day. They're inside us, they're surrounding us, they connect each of us to nature, and understanding these patterns helps reveal why the things from our bodies to buildings are shaped the way they are and why they function how they do.
That's really interesting. You're saying it's even involved in music, which makes so much sense because you kind of count the beats and all that kind of stuff.
I
Like it
know.
makes so much sense. Maths is everywhere.
Yeah. So to start off, Ali is going to drop us a beat. Do you want me to give you a beat? You rap over my beats. Ready?
Oh God, no.
Ready?
I
Here
think
we go.
No, actually,
One,
you
two,
were,
three. Don't switch this
you were-
around,
you
Ali.
were
Don't switch.
supposed to
No
rap.
swapsies.
We did say
no
after you were
swapsies.
singing Taylor
Ready?
Swift.
Right.
Look back on previous
So I
shows
sang
to watch
already,
her
so
sing
now
Taylor
you clearly have to sing.
After that, we said that you had to rap on next week's show, and you didn't rap last week, so you got to rap this week.
Give me a beat. Give me a beat.
I left my beat roots at home.
You can't beatbox.
Give you a beat. No, can you beatbox?
I think you just go. Pff.
Oh, that's what you.
Okay. Okay.
Did I do it?
I gotta get someone else to give me some
Okay,
beats.
yeah, that's not my forte.
I gotta get someone else to
Okay.
give me some beats. So throughout the show, we're gonna do some puzzles, but we want to get to awesome Science Week story this week.
Oh, yeah.
Mars was the closest it's been to Earth until 2035. So it came about as close as 62 million kilometers. I got my ruler out and I was kind of
Oh,
like
yeah.
just checking the kind
It's
of
a
distance.
very long ruler you got.
Very long ruler. It wraps up like one of those
Oh, okay.
things.
It just takes up your entire room.
Yeah,
like.
it just forms a spiral. Again, maths involved there
Maths,
too.
yeah.
But Mars has been the closest it's been for a very long time. So there's the beautiful fourth planet from the sun, the red planet Mars,
Look at it there.
with its ice cap. See its
Yeah, it's
frozen
got
ice
a
cap at
North
the top.
Pole.
Yeah, and you're actually going to see that.
Does Santa live there?
No.
The Earth's North Pole.
Well, maybe he does.
Maybe there's a Martian Santa.
Maybe there's a Martian Santa. A manta.
A manta. A manta ray.
A manta
I
ray.
love manta rays. They're like my favourite animals.
We're getting completely.
Sorry, Mars.
Yeah. So you can see that Mars' orbit is highly elliptical. So you see, this is kind of an image that kind of shows you why Mars gets closer and further away to Earth. So you can see that right now Mars and Earth are at that point where they're at the closest to each other. So just over 60 million kilometers. So pretty cool.
Yeah, you could run it.
You couldn't. I know that. I know that for a fact.
My dad could run it.
Oh, good morning, Nora. Nora Patton is
Hi,
also
Nora.
joining us as well. We had an awesome live Q&A, which you can check back out, where Nora told us all of what it's like to be an astronaut.
And most importantly, we learned about the space toilet.
We learned about the space toilet. Many people interested of how to go to the bathroom in space. Nora did tell us.
Yeah,
Ali,
thank you, Nora. Thank you.
question answer satisfied?
Yes.
Yes.
100%. And I'm glad
Okay.
to see that NASA are investing so much money.
23 million, NASA.
So
New
much
toilet.
money in a toilet.
In a toilet.
They can just go to B&Q.
Now, Ali, maths is everywhere around us, and that's kind of inspired me to study maths.
Mm-hmm.
And I'd like to play one of my favorite actually games this morning.
I love playing games. Okay. Yeah, I'm on board.
So, Countdown.
Oh, yes.
It's one of my favorite shows. It's awesome, specifically the numbers round. So
yeah, it
so
is.
that was
It is
really fun.
Maths Week, not Words Week.
No, it's maths
Maths week. So we're
So
going to play the maths
we'll play.
round.
You up for that numbers game?
Yeah.
We'll play the numbers game.
Yeah.
Countdown. You guys at home can do it as well. So let's check out. So we're gonna play.
Paper and
now,
pencil ready to go.
obviously, we're in Explorium, so it's a different kind of game of countdown. We'll call it Street Countdown.
Welcome to Street Countdown! First rule of Street Countdown is that you really must try and tell as many people as possible about it. It's a rather fun game, and the more people will tell about it, the better.
It's time for Street Countdown.
I'm kind of scared of street countdown. Do we have to go outside?
No, Street
cold
Countdown
outside.
is pretty much the same as normal countdown, except we do it in the street.
Taking it to the streets?
Taking it to the streets. So live at Explorium, we're gonna play a game of countdown, which you guys play at home with us as well.
Yeah,
we're gonna
play
see.
along.
We're gonna see what we can do. So we have our numbers set out
Yep.
here. We have large numbers and we have the smaller numbers, and we have our board here. So Ali, I think it's time that we just need to get our pencils ready.
got my
You gotta
pencil
get
and my
our-
paper
our
ready.
pencils ready. Okay, got our pencils ready here.
I'm going to let you pick the numbers for the first round.
Okay, sound.
Okay, so
Really nice of you.
how many larges and smalls would you like?
Ali, I would like one large and 5 small.
1 large, 5 small.
Yes, please.
Okay,
Yes,
so you got
please.
75.
Okay, we're gonna write these down. So 75,
75. A 5.
a 5,
Let's go with a 3.
3.
Grab one from over here. 7.
a 7,
From the bottom, a 2.
a 2.
And another 2.
Oh,
Okay,
another
I gotta write
2.
them down. Hang on.
Yeah, I'll give you. You can
75,
write them down at home as well.
5,
You have time. We're gonna come up with a
7,
random number
2.
generator.
2. Okay, I got them
And
down.
if anyone's crazy enough that doesn't know how countdown works, you have to use these numbers to get to a number that we're going, a 3-letter number, 3-digit number that we're gonna create now.
Target number.
A target number.
Okay.
Okay. So Ali, I'm gonna get the target number ready.
Okay.
So this will be our target. So okay, what do we got? What do we got? What do we got? What do we got? Okay. And your target is 727. So we'll write that down.
727.
Okay. 727.
There's a lot of 7s and 2s on the board, to
It
be
is,
fair.
yeah.
Okay.
It really is. Okay, and we need to. We've 30 seconds.
Okay.
So let's put that on the clock. 727, and your time starts now. Okay, well, the time's up. Ali, what did you get?
750.
Okay, and ask me.
What did you get, Mark?
727.
Oh, would you like to tell us how you got your 727?
Yes. Okay. So I would like to start off with the. We're gonna go. Let's see. The 5 multiplied by the 2.
Okay.
Okay, I'll
Is
give you a 10. You got your 75, so I'd multiply 75 by 10. You should get 750.
Okay.
Okay. And then we are going to multiply the 7 by the 3. You get 21.
Accurate.
Okay. And then we're going to add the 2 to that.
To that.
Should get 23. And 750 minus 23 is, if I'm correct, 727. Yes! Zing!
Okay, I want another round.
Another go?
Yeah, I want to go again.
Okay, go again. Okay, go again.
This
Okay.
one, I'm picking the numbers this time.
Hello, Sir Jane. Good morning. Hello, everyone who's joining us. We are playing Countdown. Get your pens and get your papers out. We have a mathematical challenge where we're going to reset. We'll have another game.
Yeah.
Okay, let's have another game. And
I'm going to do a bit of a souffle here.
Oh yeah, do a Michael souffle.
A Michael souffle.
Okay, so
What's your favourite search engine? Mine's Michael Google.
Michael Google. Okay, when we're going to get a new number generator.
I'm going to pick my numbers
Oh,
first.
you pick your number.
Okay.
So I'll be Rachel Riley. Okay.
Not Carol Vorderman.
I'll be both. Carol Riley.
Brilliant.
From Wexford.
Rachel Vorderman.
Yeah.
Okay, I would like 2 large
Oh,
and
okay.
4 small, please.
Okay, 2 large and 4 small. So I'm gonna go. Oh, bit of a diagonal.
Oh, a diagonal.
Bit of a
Nice.
diagonal. Okay. So we have our large numbers as 25.
Oh.
Ooh, 100.
Oh, that's my favourite one. I love when 100 comes up.
Very excited there. We have our 4 small being 6.
Cool.
Oh, another 6.
Oh.
A 4.
Okay.
And a 3. Okay. So I'll just watch.
I hope the thing we're looking for is 664.
Okay, so let me write these down though. So we got 25, we got 100, 6, 6, 4, and 3. Okay, so let's get our next random number. You ready?
Yeah, ready.
Okay, so our target number this time will be, whenever it's ready, 146. Okay, and we'll get the clock up. Here we go. Okay, so we have our sound effect, Ali.
It's such a tune.
Okay, you ready?
Oh, I don't know now.
We have
I'm scared.
30 seconds starting now. Okay, so.
Okay.
This is tricky.
I think I have it.
Oh,
I have it, but it's not written down. That's what
have
they
it,
say,
but it's not written down. Then you got to get to it quick.
That's what they say.
Okay, let's get to it straight away. Ali.
Okay. That's. Do you have it?
I can't. You have to go straight to the
100 plus 25.
100 plus 25. We've got 1, 2, 5.
Plus 6 is 12.
So we've got 6 plus 6 equals 12.
Should give you 137.
So we've got 137 when we've added those two together.
I don't have it. 137 plus 7 is. Oh, I can get 2 away in 2 different ways.
I think I've got 139.
I had 148 and 144.
Nobody
I couldn't
cares,
get.
Ali.
If anybody can get 146,
yeah, let us know in the
comments.
comments if you've got 146.
We're going to recap on the numbers there for you. So we got 25, 100, 6, 6, 4, and 3.
And where would mine? Oh no, no. Well, I have got 139. I've got the
I've got 148.
That's.
It's 2 away.
You can't. You already got 137. You can't.
No, I wasn't finished. I realized. Okay, but then add the 4 and the 3 to that. So
you add the 4 3, so you're adding the 7 to it.
So
you're gonna get 143.
144.
You've added 7 to it.
144. So I can get 144 and I can get 148, but I can't get 146. Oh, people are doing maths in the comments.
Oh, here we go. Okay, David's with us, David Malone. So, let me see. We have 25. Oh, absolute. Keith Grennan. Absolutely. 25 by 6 minus the 4.
Keeping it simple.
So 25 by 6, you'll have your equals 150 minus the
Minus your
4
4.
equals 146.
Dave Malone also has it, so he's 6 divided by the 3.
Excellent,
gives
Keith
you
Brennan,
2.
you are correct. And Dave Malone is going to go, so you have 6. You have the 6 divided by the 3 gives
Giving
you the 2.
Multiplied by 25 gives you 50.
50 minus the 4 is 46.
Multiply that by the or add that to the 100,
Oh,
146.
lovely. David Malone on fire. Keith
Well
Brennan
done.
and David Malone, congratulations. Well done.
You are
Excellent.
the countdown
You
champs.
are our countdown
Well
champions.
done.
Okay.
That was fun. I love countdown.
Love countdown.
I'm kind of raging. I didn't get
Kinda
either round,
raging.
but
Kinda raging.
kind of raging.
Kind of
that
raging.
was fun.
That is super fun.
Yeah, I love that.
And and Ali, you have a bit of a mathematics trick for us as well.
I do have a little
I was
maths trick.
super impressed with. Now,
okay.
again, please do try this at home as well. Let's see if Ali's mathematical trick can work, because there are lots of relationships between numbers. They're super fascinating. You can do so many things with them, including lots of different types of mind reading tricks.
What I'm actually going to do here
Yes.
is I'm going to use maths to predict the future.
You're going to use maths to predict the future.
Yes,
Okay.
that's
One of the
the
things
plan.
maths is fantastic at doing.
So Mark, I'm going to need you to help me with this.
Okay. Let's.
Get ready to count down.
Okay.
We're done with countdown.
I'll help you with this.
Okay, so what I need you to do, and you can try this one at home
Please
too,
do.
is I need you to give me any random 5-digit number. Okay, so the 5-digit number can't begin with a 0, because then it's not a 5-digit number. And I'm also going to ask that it doesn't begin with a 9.
Okay.
So if you want to just
And I can tell you.
shout out 5 random numbers in.
Okay. 4,
4,
7,
7,
1,
1,
8,
8,
6.
6.
Okay.
Okay, so based on your 5-digit number of 47186,
Yes, Ali's bank number.
I'm gonna. I was like, is it? No, it's not. Okay, based on that, I'm gonna make a prediction here. Okay.
Okay.
Don't look at it. Don't look at it.
Don't look at which.
My prediction.
don't look at anything. Okay, so we have the 47186. Okay. Ali's up to some mind reading maths magic over here.
Okay.
Okay.
Okay. Yeah. Okay.
Okay.
That's my prediction, and I'm gonna put it away over there, so we
Okay.
can't look at it. Okay. So, Mark, what I want you to do now is I want you to give me another 5-digit number.
Okay.
Yeah.
7,
7,
8,
8,
9,
9,
1,
1,
3.
3. Okay. Now, to keep it fair, I'm gonna pick a number.
Yeah, that's fine.
Okay, so I'm gonna pick a 5-digit number.
I've no problem with that.
And I'm gonna go for 2, 1, 0, 8, 6.
Okay.
That's gonna be my number.
Okay.
Would you like to give me another number?
Oh, I would love to.
Yeah.
Another 5-digit number.
Another 5-digit number.
Okay. 112
1, 1, 2,
95.
9, 5.
Okay.
Your birthday.
It's my pin number.
And then I'm gonna pick another number. I'm gonna go 8, 8, 7, 0, 2.
Ooh, a 7.
Seven.
Ooh,
A 7. Okay.
Seven.
So, Mark, what I need you to do now is I need you to add those numbers together.
Huh?
Add them together.
That's not working. Ooh. Okay.
Okay, I'll do it too, so we can confirm
Yeah.
that we've got the maths right.
Okay, so we've got a 22.
Okay. Okay.
And we have got a 28.
28.
We got 21.
Okay.
We got 27. You double checking me?
No, I'm gonna double check after.
Yeah, okay, grand. And last one we have. So we got 10, 11, 13. Okay, and we've 24.
24. Okay. Your math is wrong, first of all.
Uh-oh.
Redo the first row for me.
We've got 9, we've got 25, we've got 30, we've got 32. That's what I said! 32? 32?
6 and 6 is 12.
Yes,
Plus 3
yes,
is.
yes.
'Did I do
15.
my maths wrong?
22?
You picked this number, this number.
I did.
Did I pick this number? No, I picked this number. You picked that number. Oh, sorry, my bad. My number here. I'm gonna change my number here.
Okay. Okay.
Okay.
This is like
Math
a
of 4.
mathematician who's wistfully searching through the deck. Is this your card now? Is this your card? Is this your
Okay.
card? Is this your card?
Mark,
Uh-huh.
would you like to read out my prediction there?
The prediction is 247,184. And you made this prediction after I said this
The
number.
first number. Yeah.
Ah, so we will say that the number is correct.
Okay.
And That was pretty cool.
Yeah, so you picked 3 completely
I
random
picked this number, this number, and this number.
You picked 3 completely random numbers. I added 2 numbers to it, and that was the prediction.
Can you tell us how you did it, Ali?
Yeah, I can. Yeah. Okay. So let's do another one, and I'll talk you through it step by step.
Will we?
Yeah, let's do it. Yeah.
Okay.
Okay, I'll talk you through step by step. Okay. So, Mark.
Yes.
Give me a 5-digit number. Let's go.
1, 2, 3, 7, 9.
7, 9. Okay.
Okay.
So I'm going to make my prediction purely based off your number here.
Okay.
Okay. So I'm going to write down my prediction again.
Yes.
For this one, and this time I'm going to do. Okay. My prediction this time is going to be 212-377.
Okay.
Okay, that's the prediction this time.
Okay.
Okay, you get your friend to pick you another number. Go for it.
476
4,
1,
7,
2.
6, 1, 2. Now, after Mark picks his second number, I'm going to pick some numbers.
Okay.
I want you to pay attention to the pattern of the numbers
I will.
I pick. Okay. So my first number is going to be a 5.
Okay.
My second number is going to be a 2.
Uh-huh.
Then I'm going to throw in a 3 in there, an 8, and then a 7.
Okay, great.
What's the pattern? Look
That.
at your number and my number.
They add up to 9.
They add up to 9. Yeah.
Yes.
You give me another number.
1, 2, 3, 4, 5.
1, 2, 3, 4, 5. So what do you think I'm going to pick this time?
You're going to pick 8,
Yeah.
6.
7.
Oh, that goes up to 9.
Up to 9, yeah.
7,
8,
6,
7, 6,
5,
5,
and 4.
4. So when you add those together,
They're
these
going to add to
two,
9.
99,999.
Yeah.
These ones are going to be 99,999.
Uh-huh.
So when I made my prediction,
Yes.
all I
So
did,
you know what that's going to add up to.
I know what that's going to add up to.
Yes.
So the prediction is we take Mark's original number, we take a 2 away from the end, so we get a 7, and then you put a big old 2 in front here.
And why? These numbers add up to.
Almost 200,000.
So we'll have 1, 9, 9, 9,
9, 8.
So this will always add up to this number.
Yeah.
And you know that ahead of time.
Yeah.
So you need to take this number
Yep.
and what?
And add 1,999,998 to it.
To this.
Yeah. And the quick and easy way to do that is to take a 2 away from the end and put a big 2 in front. That's how it's done.
So you would have
That would become a 7, and then you put a 2 in front of
a
it.
2 here. And
And
your
then
number would be
212,377.
2, 1, 2, 3, 7, 7.
Yeah.
Very
And
cool.
that's how
The
it's
fun
done.
you can have with mathematics.
Yeah, who knew?
Try to help. You've absolutely blown Fleur's mind.
Sorry, Fleur, it's a bit early for mind blowing. I do understand.
That was really, really fun.
Thank you.
Now, we are going to celebrate some Irish mathematicians, of which there are many.
Many.
And we're going to mention a few today. We've got one of the world's best mathematicians, William Rowan Hamilton, who was Irish. He was
Irishman, yeah.
a professor of astronomy in Trinity College. He was an astronomer and a mathematician.
Yeah, and he lived at Dunsink Observatory for like all of his life, didn't he?
Observatory.
From the age of 20 odd.
Oh, very cool. Made lots of advancements in algebra,
Yeah.
optics, and mechanics. So one of the world's greatest
Yeah,
mathematicians.
and he
Irish.
actually, something I found really interesting about him was that he made his discoveries while he was going for walks.
All of them.
And we're all going, well, some of them's best ones, and we all go for walks at the minute during lockdown. So
What
maybe
do you do on your walk?
So maybe when you go for your walk, you could come up with the next mathematical scientific breakthrough.
Oh, bit of
No
pressure there. Yeah.
No pressure.
Heading out for an old brisk walk. Oh, discover any algebraic relations and problems. Make any discoveries.
No,
No.
go back out.
I got wet. So, we also are a very kind of famous Irish physicist, chemist, Robert Boyle, who we celebrate here in the Robert Boyle Summer School, the Winter School, which, because Robert Boyle is from Lismore in Waterford.
Waterford, yeah, in 1600s.
1600, so he's going back even further away. And again, people have created and discovered these relationships which they use maths to describe, and Robert Boyle came up with a very popular one which you might know about called Boyle's Law.
Boyle's Law, not B-O-I-L.
No.
Not those kind of boils.
Not boiling.
Not, Oh, I was
Robert
going with
Boyle's law.
like swords, like boils.
Oh,
Like,
ew.
yeah, I know, right? Not that
Ew,
kind of law.
Too early for
I know,
that.
right? Sorry, I take it back.
So now Boyle discovered this experimentally, but again, it can be described mathematically, and we're going to show you visually. Oh, lots of experimentally, mathematically, visually. We're going to do all of these things to show you Boyle's law in action. Ooh. I'm going to clear this off, and you can get some of the apparatus which we'll use for today's experiment.
Okay, so for today's experiments, we are going to use a balloon pump. Okay, we're going to use some bottles. You put some stuff in the bottles.
You put some stuff in the bottles.
What did you
I did.
bottles?
Now, on Boyle's law, we're going to show that the pressure is inversely proportional to the volume. What that means is if you double the pressure, you halve the volume. So pressure and volume are related to each other. This is what we're going to show you with this bottle. So let's start with this. I put a balloon inside this bottle. This is very fun to do at home as well. Now, to get the balloon in the bottle is a little tricky, okay? So what I did was I got the balloon, you put it inside the bottle. And as we've known now, those of you who are watching Super Science Saturday by now know that air is made up of stuff. It has weight, it has pressure. So this bottle is already, when it's empty, it's still full of air. Might not be full of liquid, but it's full of air. So if I put the balloon in and it covers the top and I'm trying to blow more air into that, the air inside the bottle has got nowhere to go. So it won't allow you to blow the balloon up.
It fights against it.
So what a little trick we can do is when you put the balloon inside the bottle, leave a little gap for air to escape out. So I get a straw and just put it down like that. So when your balloon is inside, there's a little space that allows air to escape out of the bottle and allows you to blow up the balloon.
The air in the bottle can get out. It's not fighting against the air trying to go into the balloon.
Make some space for the balloon to blow up.
Nice, okay.
Then you just tie it and push the balloon down into it. So here we have a balloon full of gas, full of air. And what I'm going to do is I'm going to increase the pressure inside the bottle.
Okay.
And from Boyle's law, if you increase the pressure, you have to decrease the volume. And we're going to try and see that visually. So check out the balloon.
Pretty wedged in there.
Isn't it? Yeah. It ain't moving.
It ain't going anywhere.
It ain't moving. So if I put this little pump, we're going to put that on the top and keep your eyes on the balloon, okay?
Ooh.
Check that out.
It would not move down there. Oh my god, it's getting really small.
Yeah.
Ooh. You're struggling there. There's a lot of pressure building up.
The pressure is building up. It's harder and harder.
Oh my god.
But check that out.
So you
can see
increase the pressure in the bottle,
which you can feel.
Yeah, you really can. So then that decreased the volume of air inside the balloon.
Exactly. It got stuck inside.
Oh, look at that.
Look at that. And the balloon
wedged
goes back
again.
to the normal size. So as you can see, Boyle's law, it kind of visually and in action, increasing the pressure decreases the volume. And it works the other way around as well. If you increase the volume, the pressure decreases proportionally as well. Now, Ali, you have a very fun and edible version of this, don't you?
This morning I felt like I didn't want to fill up my water bottle with water, so I filled it up with mini marshmallows. Mini marshmallows. So what we're going to do is we're going to mark on the bottle.
Me?
It's not all about you, it's about Boyle. We're going to mark on the bottle where the marshmallows are coming up to. So they're kind of coming up to this line about here. Okay. So we're going to do the same thing again as we did with the balloon.
Okay, so you're going to try and increase the pressure.
Yeah.
And that will decrease the volume inside. Okay.
That's the plan. So let's give it a go.
Oh, they're shrinking.
They're definitely moving downward.
They're shrinking. They are indeed. Look at that.
Ooh. It does get tough.
You're vacuum packing our marshmallows.
And our marshmallows are shrinking inside
and it gets tougher, doesn't it?
It does get tougher.
It does get tough.
I'm going to try and not get the pump stuck inside, but if we mark that again.
Oh, a lot of it, maybe. Okay.
We got down to about here.
Well, look at that.
So from here down to here.
Now, the balloon clearly had gas trapped inside it, but marshmallows do too. They have little air bubbles inside them and they're trapped. So that's what we're doing, increasing the pressure in the bottle, and that's decreasing the volume of those little air bubbles inside the marshmallows, shrinking them down. Cool if you're going on holidays and you only have stuff your suitcase full of marshmallows.
That's why those vacuum sealy bag things work.
Sealy.
You know what I mean? You always see them on, like, you know when you're up way too early and you're seeing like those teleshopping ads and there's ones about like vacuum.
No, I wouldn't. I have a very regimented sleeping pattern.
No, you don't. No, you don't.
Now, Boyle's law can be seen and experienced. Most of you will have experienced Boyle's law before because when you're on a plane and your ears pop, Boyle's law.
Or if you're scuba diving and your ears pop.
Yes, absolutely. Even if you bounce a ball, when the ball hits the surface, that's decreasing the volume inside it because the ball changes. So if you decrease the volume, you're increasing the pressure. That's what causes the ball to bounce back up to its normal size.
That's cool.
There's also another more relatable thing that we can describe Boyle's Law with, and that's the fizzing inside a can.
Oh
when
God,
you
yeah.
open a can and it goes
too much.
which happened numerous times in this show as well.
It has actually happened on this show already, yeah.
So those cans are pressurized, and when you pull the lid, it releases the pressure, the volume of the air bubbles inside increase, and all the fizz comes out like that.
Oh, okay.
And makes the...
That was actually your sound.
Yeah, it was good, wasn't it?
Yeah, do it again.
I've been practicing.
Do it again.
No, I won't do it again.
You can't do it again.
It was really lucky. Ali, I've got a game.
Okay.
It's called Boyle's Law Roulette.
Ooh,
oh, this is where we should have that kind of Chinese type game show thing where it's like Boyle's Law Roulette. Thumbs up. We'll work on that.
Castle.
Yeah, yeah,
No,
yeah.
Ketch's Castle.
Okay, so Ali, I have got I got a bag of cans. A big bag of cans, okay? And there are 6 cans, and I am going to shake one of those cans up. So we don't know. So I'm gonna shake one of them up. So I'm gonna pick one and I'm move them around.
This already sounds like a bad idea.
Yeah, okay.
Oh, you're really shaking.
I'm gonna shake one of those cans up big time.
I don't like where this is going.
And we're gonna play a game of Boyle's Law Roulette.
Okay.
So the can will be. Don't look at it.
Oh, sorry.
I gotta shake it up real good. So, okay, we're good.
Okay.
Did
you open it?
No, I looked where the bag is.
Okay.
And I'm gonna mix them up again now anyway.
Okay.
Okay. Okay. I'm gonna put cans out.
Okay. I'm helping.
Okay. One of these has been shaken up
to within an inch of its life.
Terribly. And we're gonna see who's gonna get splattered all over the face. Okay, we need a bottle.
Excuse me?
Okay.
Bottle.
One of these I've increased I've shook it up a lot. So when it's opened, it's gonna explode. Do you wanna go first? Yeah, good point.
I'll put my goggles
Safety on. Safety on.
Okay.
Oh,
it's a very spinny bottle.
That's a very spinny bottle. We will be here forever. So
unless one of us gets it in the first round.
How's the family?
Fine, yeah.
Nice weather we're having outside
it's
there.
Definitely slowing. I didn't even spin that very much.
And it's going to be the closest one to the clockwise version of it.
Okay. Am I going number 12?
You're going with that one.
Okay.
Okay. And I'm not going to spin it as much.
Am I opening it?
Oh yeah, open it.
Ooh!
Oh.
Victory sip.
Well, luckily I don't like fizzy drinks. Okay, here we go. Which one's it gonna be?
Oh,
I got this one.
Iced tea.
Okay, here we go. Oh, clear. Okay, I'm clear. Okay.
The stakes are getting pretty high now.
Okay, they are. Okay. Let's spread them out. Okay. Oh, there you go.
Okay.
In you get. Get your face close to it. Okay.
Oh, I really hope you get splashed.
Not many left.
Oh, that was not a spin.
Now, hopefully, it was shaken up enough.
You did a lot of shaking.
I did a lot of
shaking.
shaking.
No way it's not going to explode.
Okay. I would say. Okay, which. This one?
Yeah, I'm going to say
okay. Okay, here we go. We're clear. Okay.
Do we just pick one at random each and go for it?
Huh?
Do you take this and I'll take that one?
Okay. Which one did you say?
I'm taking this one, you're taking that one.
Okay, at the same time?
At the same time.
Okay.
Okay.
Hey. Oh, pick it up.
3, 2, 1.
Yes! Boyle's Law in your face! Your face!
In my face, in my hair.
Oh, spilled it everywhere.
Oh, so I don't want this arguably the worst smelling one as well.
He's like Boyle's Law in your face, Boyle's Law in your hair. Oh, that was fun.
Why did I cross over? I should have left with the one that was in front
Marissa,
of you.
thanks so much. We're glad you enjoyed these Boyle's Law experiments. Do try these at home as well. They're very fun, especially when one of you gets covered in the sticky soda. Oh, thank you to Fleur as well, who's pointed out that Boyle's Law explains how breathing works inside our body as well. So yes, how our lungs breathe and the air goes in and air goes out with our diaphragm.
Of the lungs.
Absolutely. Thank you, Fleur.
The table is wet.
The table is sticky. The table is very sticky. Now, Ali, that was super fun, but it's time for next week's challenge.
Ooh, next week's challenge.
And this is based off one of my kind of favorite films, and a challenge that I seen when I was really, really small. I was like, that is so cool. Okay, so this is next week's challenge.
On the fountain there should be 2 jugs. Do you see them? A 5-gallon and a 3-gallon. Fill one of the jugs with exactly 4 gallons of water and place it on the scale, and the timer will stop. You must be precise. 1 ounce or more or less will result in detonation.
So, this is the Die Hard riddle. What you have to do is... That is the Die Hard riddle. What you have to do is you have to get 4 liters exactly. You have a 5-liter gallon jug, a 3-liter, and you have to use them and water at your disposal to get 4 gallons in one of those jugs. That is your challenge. So you can write it out mathematically or experimentally do it at home as well. But mathematically, logically work out how you would get exactly 4 liters in one of those jugs. That is next week's
That's cool.
problem. Pretty cool.
We're going to need some big bottles to show the solution to this one next week.
Yes, true. Or we can do it mathematically. That's what's great about maths.
That's week.
Because if we're trying to go up and describe something about a black hole, you can't go there.
You can't go there and do it.
You
That
need
makes
someone
sense.
like Stephen Hawking to come up with some mathematical equations that describe what's happening.
Makes sense.
Yeah,
Makes
that's
sense.
what's cool. That's what's theoretical about theoretical physics.
Yeah.
Now, Maths Week is super fun.
Yeah.
There's lots of really cool things going on. So you can actually check out the Maths Week website to see the different kind of resources and the different things that you can do.
There's other good like puzzles and riddles and challenges and stuff on there. They're good fun.
I love a good puzzle.
Yeah.
Love a good riddle. They are super fun. So do check those out. Have some fun. Enjoy maths. Look everywhere around you to see where maths appears in nature.
Yeah.
And even if you send some pictures in of where you've discovered mathematics in nature, send them into the Explorium social media accounts. Have a great final day of Space Week.
Space Week.
And kicking off Maths Week.
Maths Week!
Maths Week. So guys, have a happy Maths Week. Have a happy Saturday. Thanks for joining Mark and
Ali.
we should probably say that. We never say that at the start.
Sometimes we forget.
Sometimes we forget
we're
our
all
own
friends
names.
here now.
We're all friends, here now. Thank you to all of you for joining us, and do try some of the puzzles, some of the riddles. If you have a riddle of your own, send it to us.
Yeah.
That's what we would love. So send us any riddles or any puzzles you have on the social media account. We'd love to try them and enjoy them throughout Maths Week. So that would be super fun, super cool. And
this is a Super Science Saturday.
this is Super Science Saturday. Have a happy Saturday. Bye
Happy
bye.
Saturday.